Hello, thanks for the introduction. Today, I'd like to first introduce some backgrounds on why we want to pursue the social media route of drought information. In Utah, the drought situation has two important issues that we face. The first one is a decadal drought cycle, which is quite strong, and then it outvaried the long-term change. So it is quite important that we understand the cyclical behaviors. The other one is the lack of data. This map is the population density, and you can see how sparse the observations can be because they correlate with human population. On the drought cycles, we have done research to link it with the ocean atmospheric variability to forecast the Great Salt Lake annual level. On the lack of data, we established some informatics system to try to fill in all the data. We cover areas like a snowpack, evapotranspiration, stream flow, water storage, and also soil moisture. Take the example for the stream flow. You can see that you can click on major rivers in Utah, and it will try to provide historical flow data going back to many, many years with triggering data as well. That doesn't really solve the lack of data issues. So in Climate Center, we try to establish as many stations as possible. Maintaining these automated stations is not easy. And we have a dedicated team trying to make sure that all the stations functions properly. So these are how the 150 stations are maintained. So with the installation of these stations, we can now try to compute drought indications like a PDSI using these ground truth weather stations. This is current drought evolution in Utah. You can see that a few dots that shows up on the map, they are not consistent from other meteorological data. So this is the evolution of drought in Utah from the West-wide drought tracker. And here is how we recompute this drought situation. Even though they are quite consistent, you can see in the wet phase and also the transition phase, there are some discrepancies. Even with the informatic systems, there's still a lot of gaps to fill. So that's why we're engaging in human to collect the social media data, such as Twitter. And here is just a variety of words that we used from Twitter. With those tweets, we will conduct the sentiment analysis, and then we create an initial sentiment analysis that give each tweet a positive and negative score. Then you create a matrix of data, and then you can start to do the analysis on that. Here's an example in the tweet. And if you plug this into the sentiment analysis, it gives you some scores, right? So this sentence will have more of a negative sentiment. And then you can analyze these scores from each tweet. It's not as easy as it sounds because you really need to perform data cleaning. It is quite important because they could mention drought, but then they could mean completely different things. And then we found out that in Utah, the data source is limited because it appears that people in Utah don't really tweet about drought. So we don't really find much information that can allow us to build enough realizations. And it turns out that it is not surprising because in a very recent research done by University of Nebraska-Lincoln has shown that Utah is among the states that don't really have a good correlation between drought and tweets about drought. So, to remedy that, we try to be proactive. We try to engage in news media. In this case, the radio stations, public radio, and also local TV stations to encourage the citizens to tweet about droughts. There are a lot of gardeners, ranchers, and small farm holders who monitor droughts quite frequently. So we just encourage them to feed into the social media. In the meantime, we have to seek data from our neighboring state, Colorado, to analyze and build our sentiment analysis model. So the previous analysis used about 3,000 more tweets that goes from January through June this year to understand the current drought situations. And this is what the negative sentiment tweets looks like with the various of filter. This is the ratio of negative and positive sentiments. And you can also plug in all the different combinations of tweets and also the sentiment scores. So here's just a couple of examples. And then you can start to compare with the drought evolution from the state. So this is how the drought in Colorado has evolved. The tweets are probably more reflective about the world's drought. The more severe the drought, the more correlated they are. We also found quite a different category of drought calculated from the GRACE satellite, which detect the micro change in gravity. And then, an important function of GRACE satellite is that they can detect shallow groundwater, water storage changes. And through the second line, you can see that it appears that the ratio between positive and negative tweets and the groundwater drought, they have some sort of relationship that prompts further interest here. First of all, they seem to be inversely correlated. And this is quite intriguing. But if you think deeper, this is not quite possible because groundwater drought and groundwater status takes time to react to weather conditions. So we are not too sure about this inverse correlation. But if you look at the data again, and it could be possible that there's a phase shift, then if that's the case, you would really mean something, because a phase shift means that if you monitor the rate of change of tweets or sentiment of the tweets, and it's likely that you can observe or predict, the groundwater drought status from a week to several weeks ahead. But this is very preliminary. It requires a lot of different combination of tweets, and also have to consider different scale, part of the state or regions bigger than the state. We also have to take into account the retweets and also different types of droughts. So it's an ongoing process. Moving forward, we are trying to acquire and clean more data, beginning with Colorado throughout November this year. And we also will analyze earlier years. And after that, we hope that we can then reapply this model back to Utah. By then, we hope that we can get more data from Utah. I'd like to really thank Joe to accompany us and to learn through this process and provide feedbacks. This project couldn't have been successful without Sabaji, who is a computer scientist, and also Hongping, who is a climate modeler. And I really very much thank NIDAS for providing support for conducting this data set. Thank you.